Okay. Oh dear, it's all a bit crazy. My daughter's bike just got stolen. Well, don't know if it just got stolen, but it got stolen from outside the local station, and so that's a bit rubbish, and sad, and so everything's a bit kind of and stuff. No, do that thing there. So yes. Right, anyway, never mind stolen bicycles and all that nonsense. Welcome. And that's interesting. So yes, welcome to C# School of Grok. We are going to learn stuff. I've had to switch to this microphone because my other microphone's not working either, so that's completely thrown me for a loop. So yes, last week we sort of looked at installing .NET and getting started with C# and the Hello World program and getting some input and all that sort of stuff. So today I want to start looking at some other things, building some more interesting things and learning about some stuff about data types and things. And so we're going to start building a proper application. So I'm off my virtual machine and back onto my normal machine, so things look a bit different. And so I thought we would build a calculator because back in the day we all used to use an operating system called Unix for building kind of business systems and that sort of stuff. There are 16 zombie processes, and these days Unix has kind of gone away, but we have Linux, and so Linux had everything in, or a lot of things in Linux and Unix. It was all command line. There were no Windows actually back in 1989 when I started. Windows was still really new, and that kind of operating system was still really new. And so most things were done with the command line. And so there was a command line tool called calc, like this, and then you could put in 3 times 19 and it would say 57, and then you could just do Control C to get out of it, or Control Z. No. Anyway, let's do kill 1179. Can't remember how you used to get rid of it. Kill -9. At some point I might do some fun let's do Linux things for a bit, because Linux is great. But yes, so there was a command line calculator, and so we're going to build a command line calculator because it's nice and simple and straightforward, but I can teach lots of things by building a command line calculator. So that's what we're going to do. I get very confused here because I've got the stream softwares on my main monitor, and then the code I'm working on is on the bottom monitor, and it just sort of throws me off completely. There we go. Because the mouse pointer is currently moving twice in my field of vision, which is really strange. Right, anyway, we're going to exit out of here. So we're going to create a new directory. So we're going to do mkdir calculator and then cd calculator. Right. So last week we just did a .NET new console and we created just a single console application. This week we're going to be a little bit more structured. We're going to build more the way you actually work with C#. So we're going to create a new solution. So we can say .NET new SLN. So last week when we did the Hello World thing, that was a project. This week we're going to create a solution which is a bunch of projects, because we're going to have more than one project in our calculator solution. And so we're going to say .NET new and then say console, and then we're going to say -o to tell .NET where to put this console application, and we're going to put it into src/calculator. Okay. So if I do ls now, you can see we've got our calculator.sln. That's our solution file that we created. And then we've got this src folder. And if I do ls src, we've got calculator in there like that. And if I do ls src calculator, in there we've got our program and our calculator.csproj and our obj. Okay. So then now I need to add that project to the solution. So I'm going to say .NET SLN add src/calculator. Okay, and that's added that to the solution. So let's open this up and see what all that has actually done. So that can go away. So we've got this solution file here. This is a Visual Studio thing, but it works just as well with Rider, and we don't particularly need it for working in VS Code, but it's there and it sort of works, so that's fun. And then in the src folder we've got our program file here, and we've got our calculator.csproj file. And so this project file tells .NET what kind of project this is and how to build it and what files are included and that sort of thing. But it's really very simple. It's a format called XML, so it looks like HTML a bit, if you know what HTML looks like, because HTML is a kind of XML. But yeah, so as we make things more complicated, we'll start putting stuff into our project files and adding references and that sort of thing, but we won't worry about that for now. So let's take our program here. So we saw this last week. We got a namespace, and then inside the namespace there's a class, and then inside the class there's a method, and this special static void main method in the program class, when we run our application from the command line, it will run this main method, and any arguments that we pass into it will go into args here. Okay, so if I want to make it so that you can run this and just give it a sum, okay, let's start with that, and then we can go and make it interactive like the Unix calc that we looked at. So you're going to run this and you're going to say like 2 + 2. Okay, so we're going to have arguments. So that's going to come inside this args array here. And so we're going to say var, we're going to say string left equals args 0, and string operator equals args 1, and we can't use operator because that is a reserved word. C# knows what operator means. It thinks it's a special C# word, so we're not allowed to use it. And then we're going to say string right equals args 2. Okay, so if somebody runs this, with 3 arguments, then this will work just fine. But if somebody runs it with the wrong number of arguments, so if I cd into src calculator and do .NET run, I'm going to get an unhandled exception, and it says system index out of range exception, index was outside the bounds of the array. So these exceptions, that's how C# handles errors. When there's something wrong with your code, but not in a way that stops it from compiling, just in a way that stops it from running, then at runtime you will get an exception. And so that's what's happened here. An index out of range means you tried to access an element or an index in this array that isn't there. Okay, so before we can do this, we need to say, is the argument array the right size? Is it the size we are expecting it to be? So we can say if args.length does not equal 3, then we're going to write an error. So we're going to say console.writeLine, and we'll say usage calculator L left op right. Okay, and then we'll just return, and that will take us out of the application. So if I now run this again, it just says usage calculator left op right. Okay, if I say .NET run, now when I'm doing .NET run from the command line, I have to use this special way of, because .NET run itself has arguments. You see all these things you can do here. So if I want to pass arguments to the actual application that I'm running, I have to do this thing where I put dash dash, and then I can put 6 times 9. Okay, and then nothing happens, but it worked, and that's all fine. Okay, and so just for the time being, let's do a console.writeLine, and we're going to use our interpolated string here, and we're just going to say left op right, like that. Okay, and then we'll worry about how we can figure out the answer. So let's just make sure that's working. So 6 times 9 equals. Right. So what we've got now, we've got our left value and our right value and our operator, and we need to deal with those. So our left value and our right value are going to be numbers, and our op value is going to be plus or minus or asterisk or /, which is computer for divide. Okay, so what we're going to do is we're going to try, and we can't just work with strings. Strings are just text, and the computer doesn't know anything about them other than that they are text. So we can't do maths with strings. We have to turn them into numbers. So what we can do is we can parse the string, P-A-R-S-E. We can parse the string and work out what number it's supposed to be. And we can do that. So the int type has a parse property on it, and it has a try parse property on it. So if I do int l left int equals int.parse left, and then down here I can change this to left int, and I'm going to jump across and run that, and that works fine. But if I were to go for some reason x, because I think I'm doing algebra, I'm going to get another exception. I've got a format exception saying input string was not in a correct format. Okay, because x isn't a number, and so when you try and pass it to turn it into a number, it won't work, and it throws an exception. So what we have instead of int.parse is we have int.tryParse. If int.tryParse, and then we can pass in left, and then we can say out int left int, then we can do something with that. Okay, but what we actually want to do at this point is say if the left side isn't an integer, then we want to display an error message. So int.tryParse, the way this works in C#, it returns a boolean. So you see here bool, so it returns true or false. If it successfully passed the string and turned it into an integer, a number, then it will return true. If it didn't, it will return false. And then if it worked, the number that it found will go into this parameter here. So this is slightly weird, but when we use this out keyword, when we're passing a method, when we're calling a method, what we're saying is you are going to set this value for me. And that's one of the only ways you can return multiple values from a method. Okay, so it's returning true, but it's also kind of returning this left int value by setting this out parameter here. So we call these out parameters. So it turns true if it worked and false if it didn't work. And what I want to say is if it didn't work, then do another one of these console.writeLine and return things. So say if int.tryParse, that means if it did work. If I want to say if it didn't work, I just put an exclamation mark here. Okay, exclamation mark in C-like languages, including C#, but also Java, JavaScript, C, C++, Rust. Hello, Lucas. Welcome from Brazil. That's awesome. Thank you for stopping by. So yeah, the exclamation mark, or the bang as we call it in programming speak a lot of the time, means not. And so what we're saying here is if not int.tryParse, so if it doesn't work, then we're going to do whatever is in the next two lines. Thank you very much for the follow. So I'm going to grab those two lines there and I'm going to put them down here, and I'm just going to change this and say error left value is not a number. Okay, and then I can do that with the right side as well. So I'm going to change this to get the left value and the right value. Okay, and so now if I do .NET run x times 9, it says left value is not a number, and if I do 9 times x, it says right value is not a number. So that's fun. But if I do 9 times 6, then that works perfectly well. So we've turned our two strings into numbers, so we can work with those. Okay, the last thing we need to do is work out what the operator is. And so what we can do here is we can say if op equals plus, then we're going to add them together. If it equals something else, then we're going to do other things. So I'm going to declare a variable here, int result, like that. And then I can say result equals left plus right. Okay, left int plus right int, sorry. Like that. Else if. So this says if it's not, so if this is true, then that will happen, and then it will jump past this. Else if says if that was false, then try this, but if that was true, it won't run any else things for us. So we can say else if op equals minus result equals left int minus right int, else if op equals asterisk result equals left int times right int, else if op equals slash for divide result equals left int divided by right int, like that. And if it's not any of those, then we don't know what it is. So let's we'll do one last else and say console.writeLine error operator not recognized, and we spell recognized with a Z because even though we're British, computers are American. I don't know if you knew that, but all computers on the inside in their tiny little hearts are American, and so we spell things the American way. Basically most things in programming were created by Americans. We're getting to that, Yak Pimp. Thank you. But yes, we will show whole integer results. We will deal with that in a moment. So then we'll return out of there as well. Okay. So this is going to say if I recognize your operator, then that's cool. And I will set the result. Otherwise, I'll just write this error out and we'll return out of here again. Okay, and so now we can say result. Okay, and then we can go back to here and we can do .NET run 9 times 6 equals 54. Yay, it's working. 2 plus 2. Yay, it's still working. 5 minus 1 is 4. Yes, that's working as well. 5 divided by 2 equals 2. No, that's not right. So yes, our calculator at the moment can only deal with integers, and certainly until I started getting into programming, I had no idea what an integer was. So I'm going to assume that people don't necessarily know what an integer is. An integer is a whole number, okay? So 1 and 2 are integers. 2.5 is not an integer. In maths, they call it a real number. But a number with a hole in it, like 0986, that sounds like the start of somebody's phone number. There's a hole in 4, depending on how you write it, I suppose. But yes, so yes, it depends on the font, absolutely. So yeah, maybe integer is not the right type of value to use for this thing here. So what types do we have available in C#? Let's go through them. We've got int I. We also have long L and short S. So these are all different types of integer, and you can see C# has keywords for them, but it's actually system.int32, system.int64, and system.int16. And the way each of those differ is the number of bits or bytes that are used to store the value. So int is a 32-bit integer, which means it can store numbers from minus 2 point something billion to plus 2 point something billion. Long is 64-bit number, which means it can store the number of milliseconds since the Big Bang or something ridiculous like that. And short is a tiny little number. We don't really use short so much anymore because computers these days have a lot of memory, but in the olden days when computers had sort of megabytes of memory instead of gigabytes, 32-bit integers were a luxury, and you only used them if you really had to. We generally used smaller integers back in those days. So those are the types of integer. And then we've got the things you can use to represent real numbers. So we've got float, double, and decimal. Okay, so float and double are floating point numbers, and that means that they store values between sort of 0 and 1 and lots more besides, and they do that according to a specification that was written in, I think, the 1970s. And that's great, but they're not very precise when you do maths with them. Let me show you quickly what I mean by that. I'm going to install something. So I'm going to install C# REPL. So C# REPL is a nice command line utility that you can use to just run C# statements from the command line. So in here, if I say 2f plus 2f, it says 4. So putting an f after the number says this is going to be a floating point number. So if I say 5f divided by 2f, it says 2.5, which is all fine. The problem comes when you do something like 4.99f times 5f, and it says that that equals 24.949999, which it doesn't. It equals 24.95. So if we use decimal to do this, by putting an M after the thing there like that, we get the right answer, because decimal is much more precise. Whenever I'm working in C# on sort of real projects, customer projects and so forth, anything to do with money, you always use decimal. And that is actually why the letter that we put after it to say this is a decimal is M. The M is for money. And some other languages actually call it the money type, because floating points are absolutely fine for things like measurements, or that use them a lot in game programming, coordinates and sizes and so forth. A floating point, that's absolutely fine. But anytime you're working with money, you want to use decimal. Definitely don't use float, because you do not want somebody over the course of a day, this minus 0.1 of a cent, or whatever, 0.1 of a penny, whatever that is, that can mount up if you're building high-speed trading systems or banking systems, and they've got thousands, millions of transactions a day going through. Then losing that 0.1. But yes, and there's a famous film, Superman 3, from the original Superman films from when I was a kid, and Richard Pryor stole a whole bunch of money from all the banks by taking the rounding things, and yes, they did it in Office Space as well. But if you use decimal, we can't do that. Exit. Goodbye C# REPL. Okay, so we are going to use decimal here instead. Okay, so I'm going to change all my things here from int to decimal like this, and then we are going to go back to here and we're going to do .NET run 5 divided by 2, and now that is going to give us the correct value, and now we can get into doing all sorts of interesting things. Thank you very much for the follow, Yak Pimp, much appreciated, and thanks for shouting out and chatting. We love the chat, and we love that emoji. That is super cool. Yes. Right. So yeah, now we can do this, and we can do interesting things like 100 divided by 3, and that's going to give us this insane thing over here. So that's gone to the maximum precision of a decimal, which is a lot of 3's. Okay. So yeah, now we can do all sorts of maths and stuff, but I want to make this a little bit more robust, because what would be nice is if I could say 100 divided by 3 like that. I don't want to have to type the spaces. Okay, so that it's not going to like that because I've typed it all in one go. So what are we going to do? Well, the first thing we're going to do is we are going to create a new class in our project, and we're going to create, so we're going to talk a little bit about classes. C# is an object-oriented language. Microsoft, they had a brief go at calling it a component-oriented language, but it is an object-oriented language. So your programs work by having lots of objects that talk to each other and work together to do things. And the cool thing about objects, so before object-oriented programming, programs were just massive lists of instructions. Do this, do this, do this, do this. And they would be broken down into functions, and so you could say call this function, and it would mean jump to this function, run through that, and then jump back to where the function was called from and carry on executing like that. And this was a style of program called imperative. And you just had, you'd break your application up into lots of different files, but all the files would just have a whole bunch more functions in them, and you'd kind of group the functions that were doing the same sort of thing into the same file. And then somebody went, hey, what about if these files where we're grouping these functions together, what if we actually wrapped those in something that the programming language itself knew about? And so if each file had its own functions and its own data, and then they could talk to each other and exchange things and so on. And so that's how object-oriented programming came about. An object can contain methods or functions, and it can contain data. It can hold its own data internally. And so we're going to create a calculator class. So we're going to call it public class calculator engine, because this is where all the cleverness is going to live. And so I've made this public for reasons that will become apparent. And then we're going to say control dot and we'll say move type to calculator engine.cs. So that has now put that into its own file. And my tab size has been set to 8 for reasons that I don't understand. Something is seriously screwy with my convert indentation to spaces. Something went really screwy with my Visual Studio Code, and I need to fix it, and I forgot to do it before we started. So our calculator, we're going to take most of this stuff is going to come out of the program class, and we're going to put it into calculator engine instead. So we're just going to say public decimal calculate, and this is going to take the string of args in here. Okay, and then we can copy and paste some of this code out of here. So let's just say if args.length equals 3, does not equal 3, and what we're going to do is put a question mark after the decimal to say this is a nullable decimal. So in C#, decimal by itself and int and short and long and float and double are a special kind of type called a value type, which means they will always have a value. Okay, so if you can't return something that isn't an integer or isn't a decimal. So what I'm going to do is put the question mark in that says this is a nullable decimal. So from this I can either return null or a decimal value. Okay, so in here I can say console.writeLine, and we need using system in there, so I'm pressing Control dot to bring up actions, console.writeLine usage left op right, and return null. So in this case we're saying return null to say I don't know what's going on here, and I'm not happy about it. And then I'm just going to go and grab all this code here, and I'm going to paste it in here like this. Okay, so then we get our left and our args and whatever else. So I'm going to delete that out, and we're going to do args 0 directly in there, and then args 2 directly in there, and we'll use args1 down there, and then I'm going to change that going to rename this variable here, and that renames it in all the places down in the code here, and so I'm pressing F2 to rename it, and then that renames it for me all the way down there. And then we can just say return null here and here, and then down at the bottom here, so we've got a method, and this is the return type of the method. So our method is going to return a value to say this is the result of what you asked me to do. And so we got the result here, and so at the end of the method we say return result, like that. Okay, so we calculated our result and we are returning it down here. So in our program class we can take all of this out and we are going to say var engine equals new calculator engine. Okay, so this is creating a new instance of our class, so an object. This is why it's object-oriented programming. So the class is calculator engine, the object is an instance of that class. I can create as many instances of a class as I want. Each one will have its own copy of its internal data and all that sort of good stuff. Okay, so now I've got my engine object here. I can say decimal result equals engine.calculate, and I can just pass the args array in there, decimal question mark result, and then down here I can just say console.writeLine. I'm just going to write the result there like that. Okay, and this should still work. And we get 3.333333, 33.33333. Okay, so the reason that we do stuff like this is that we say it makes our code easier to manage. At the moment we've only got a little bit of code, but we're going to actually make this calculator program quite complicated. And so it's nice to break things down and makes it much easier to manage the code if you break it down. And so we've put all the stuff for our calculator engine goes into this class. If we had, when we have maybe like some help text, then maybe we'll put the help text into another class called help text. So each class does something and it's responsible for that thing. Okay, so we've got our calculator engine which passes and does the actual operation. This is how we create a new instance. So we say new class and then 2 brackets. So it's like calling a method, but we put this new on to say this is not just calling a method or a function, this is creating a new instance of something. And then over here I've used this word var. So in the very earliest versions of C# I would actually have had to say calculator engine equals calculator engine equals new calculator engine. Okay, with C# 3 or 4, C# 3 back in the mid-90s, they changed it so that because the compiler can work out from what's on this side of the equals what the type of the variable is going to be, because we're saying it's a new calculator engine, so the type of engine is going to be calculator engine, and so we don't need to type it over here as well. In C# 1 and 2 you had to type it, and some of the names that you type are really long and it was very annoying, and so Microsoft added a feature in C# 3 to say you can just say var. So it looks a bit like that's become, some people coming from other languages like JavaScript or certain basic languages and so forth might think that var means it can be anything, but it's not. So once I've created this, engine is now the type of that variable is calculator engine. It can't be set to anything else. So if I were then to go engine equals 42, it wouldn't let me do that because it says I can't convert int to calculator engine. Okay, so it is of that type now. And you can only use var like this when you are specifying the type on the other side of the equals, or when the compiler can find the type on the other side of the equals. So I can't just go var foo like that, because it doesn't know what type to make, and it says implicitly typed variables must be initialized. Okay, so that's going to work like that. Right, so I want to make this work with multiple arguments, and so I am going to create something to understand these arguments better, so that if I just put 2 plus 2 with no spaces, it will still work with it. Okay, so I'm going to create another class. See, that's how this works. And we are going to say public class argument parser. Okay, and we name the class as to what it's doing, and so this one, all it's going to do is pass arguments. Okay, and so we are going to say public bool try pass like that, and we're going to take in a string array like this. Okay, and then we're going to have our own out variables here. So we're going to have out decimal left, out char operator, and out decimal right. Okay, so the arguments can just be passed in here, and if it works, it will set left and right and op to something, and it will return true. But if it doesn't work, then it will leave them as their defaults and it will return false. Okay, now oh, and we have a new type here, char. So this is just a single character. So A or B or plus or minus. So a string is a whole bunch of chars all put together. All right, and what we want to do is whatever the arguments are, however they've been put in, we want to try and understand them. Okay, so we are going to join these arguments together into a single string. So we're going to say string all equals string.join, and we're going to use an empty thing and then args like this. Okay, and then we are going to, so that will join all of those together into a single string called all. Okay, and I'm going to move this into its own class like this, and then we're going to figure out how to do this. Okay, so let's start off. We're running a bit low on time, but hopefully I've got time to introduce one more concept, and then on Thursday we'll continue down this rabbit hole and we'll learn more stuff. Okay, so I'm going to start a new shell and cd into School of Grok code calculator. Okay, and I'm going to create another project now, .NET new xunit, and the output from this I'm going to put in test /calculator.tests. Okay, and then add that into my solution like that, and then we can go back to here, and so now we have a project here, and this says unit test 1. So let's talk very quickly about what this is, what I've just done, and why this is going to come in super useful on Thursday. In the bad old days, when you were writing software, if you wanted to make sure that it worked, you would write the software and you would build it and you would run it and you would use it in whatever way it needed using to find out if it worked. And if it didn't work, it would crash, or it would throw errors or throw exceptions or whatever it might be. And then somebody, not sure who, somebody very wise and clever said, why don't we write code that tests our code? And they came up with the idea of unit testing. So rather than testing your entire program all at the same time, and if one bit of it wasn't working, the whole program didn't work, they said, why don't we write code that tests individual bits of our program, that we can run the tests automatically and see how that works. So here I'm going to change the name of this to argument parser tests, and I'm going to change the name of the file to match, rename file to argument parser tests like that. And then this I'm going to rename to parses 2 plus 2. Okay. And then I want to use my argument parser over here. So I'm going to say var target equals new argument parser. Okay, and it's not going to like that because it doesn't know what that is. It can't see that because it's over there in this project. All right, so what I'm going to do is cd into test, and then I'm going to say .NET add reference .. src calculator. Okay, and that has now added a reference to this calculator project file here to say you can see this project. So my test project here can see my calculator project here. Okay, so I now have my new argument parser there, and then I can say target dot, and it still doesn't know what that is. Restart OmniSharp. Sometimes you have to restart OmniSharp. Okay, and then we can say target.tryparse. So now we can check that this is doing what it is supposed to do. So I'm going to say var args equals new string 2 plus 2, like that. And then I can say var result equals target.tryparse args out left okay, and then I can do something with the test framework to say I want to make sure that this has returned what it was supposed to return, and so we call that assert, and we say assert.true result. Okay, like that. Now at the moment, if I say .NET test in here, it will try and run this, and it won't build because my argument parser isn't doing anything. So I can make my argument parser do something. Honestly, indent using spaces 4. Convert indentation to spaces. So I can just say left equals 0, op equals 0, and right equals 0, like that. And then I can just return false. Okay. So this will now build, but my test will not pass. And I can do that. I'm going to come back out here, clear the screen, and do .NET test again. And you see it's found a total of 1 test files match the specified pattern, and here it says passes 2 plus 2 fails. Assert.true failure, expected true, actual false, and it shows me where it happens and all this sort of thing. And so this, I can build up tests as I build applications, as I build code. As I'm writing new pieces of code, I write the test at the same time as the code. This is something called test-driven development, and it's a bit weird in a sort of beginner's C# course. I don't think I've seen one that teaches test-driven development, but it is so fundamental to programming these days. If you go on to GitHub and look at the source code for big open source projects like C# itself, like .NET, but even little things, even little sort of JavaScript packages and all kinds of things, they all have huge amounts of these kinds of tests, and people set it up so that when people push their code up to GitHub, it automatically runs all the tests, and it can kind of say, hey, I'm going to open issues and things because I ran your tests and they didn't all pass, and that's bad. All your tests should pass. And so in this course, I am going to be teaching C#, but as part of teaching C#, I'm going to be teaching test-driven development and unit testing. And it applies to C#, but I don't know of any languages that are in sort of current use that don't support unit testing in some way. JavaScript supports it, Python supports it, Ruby supports it, Java supports it. And then there are actually some languages now, some of the newer languages like Go and Rust, actually have testing built right in. So you don't have to create special project types or anything like that. You can actually just write your tests inside the code. Rust lets you write tests inside comments and then it will run them. I haven't explained what comments are yet. We'll talk about that on Thursday. So that is it for today. I don't want to make these longer than an hour because there's a crap load of information in them, and we're burning through things pretty quickly. So that will do for today. I will be back on Thursday at 8 o'clock, and when I am, we will make this test pass, and then we will write another test that doesn't pass, and then we will the other thing, so one more thing, you can do multiple asserts in a single test, and so in here we would say assert.equal to left and assert.equal plus op and assert.equal to m and right. So we say make sure that this is true, but if I cheated and just told it to return true but not set these, this says the left value should now be equal to 2 and the op value should be equal to plus, and the right value should be equal to 2 as well. And so it will fail on those. And so on Thursday, we're going to make that test pass, and we're going to make a whole bunch more tests pass. And we're going to learn about strings and chars and looking at data at a slightly lower level and doing cleverer things with it. But that's it for today. That's 9 o'clock. That's an hour. I will be back. I'm doing a lunchtime stream tomorrow at 12:30 UK time for an hour, where I'll be doing more Stream Badger stuff. So if you're around at lunchtime, or you're on your school lunch break and you've got your phone and you've got Twitch on your phone or something, then you can join from there. It'll be recorded to watch on demand. I'll be piping things over to YouTube and all that sort of stuff. So yes, and please do join the Discord. There is a Discord, and it's there. That's just popped up in the chat. You can ask questions in there. If there's something that you didn't understand, something that I rushed over because I'm a terrible teacher, then you can go on the Discord and just ask in there. There's a C# channel in the Discord. Just shout out in there and I will try to answer questions. And yeah, cool. All right then. So thanks very much everybody for stopping by tonight, and I hope I will see you again on Thursday, and maybe at a lunchtime stream. Theoretically Mondays, Wednesdays, Fridays at 12:30, but we'll see how that goes, and how many days I actually end up doing. All right, brilliant. Thank you very much, and take care of yourselves, and I'll see you in a couple of days. Cheers. Good night.